I got the second motor here with the permanent magnet rotor that I showed in the last video. It has some neodymium magnets in there, north-south, north-south. And I've been having problems because when I run this, it was having like 2.3 amps draw at 120 volts. It was pretty ridiculous. And what I've done here is I put a series cap in from the AC input, which is just the grid coming out. And I put a series cap here, and that cuts down the power input. And it's probably shifts the phase a lot, so it makes it a lot more reactive power or something. But anyways, I put a series cap from one side of the AC input into the L1. The L2 is just straight there. But there's also a run cap here between L2 and L3, which is your basic way you tune a rotovertor motor to bring the draw way down or to get more shaft power, whatever. But so I got the draw I brought it down about 10 times less now, and it goes pretty good. And so I have a 12.5 UF run cap, and I could probably tune this better than what I have right now, but this is good enough. I'm happy I got the draw down so much. So here's the 4 UF This is the A4 UF run cap that's not for the permanent magnet motor here. Let me call this a PMR RV. RV is short for rotovertor. So this represents this motor over here, and it has permanent magnet rotor in it. This motor is this 1/3 horsepower Marathon 3-phase AC motor that I like to work a lot. I can actually, at 10 amp setting on my meter, it'll say 0 watts, but you put it over in 200 milliamp setting and it'll be like about 30, 50, 60. And this is my favorite motor to be testing right here. And so I'm using this as they call it a pony motor. So it's connected to the shaft of this motor, and you get this one going up to its sine wave latch speed, which is 1800 RPM. You get this one going, now you got this one going at the same, because this is also a 4-pole as this one, so its sine wave latch speed over here is also 1800 RPM. And looks like I'm going out of focus. There we go. So anyways, here we go. This is a 4 UF run cap to this motor. Just like in the picture, I have also a 4 UF series cap on its way to power this, and then I have a run cap with the PMR permanent magnet motor. I also have a run cap there of 12.5 UF. This I could probably get it better, but it works now. I'm just going to leave it. So here we go. First, I have this motor unplugged, it's not connected. this motor will be connected. This motor will be connected, and this will start up and go at 1800 RPM. It'll make a little bit of a racket. That'll spin this motor and get it up to sine wave speed. So then when this is up to sine wave speed, I'm going to disconnect this motor, and now the power from the grid, the 120 volts, 60 hertz, will just be powering this motor, and it'll be quite high amp draw. And this is what my problem has been with this, but this series cap here has fixed the problem. So here's the series cap right here, 4UF. And so I'll take you through the steps. So here we go. First I'm going to plug it in. I don't even need a start cap. Usually you need a start cap. Okay, now it's going. It's drawing 70 milliamps. I can probably get that down to 50 milliamps. But that's okay. So right now I have this run cap, 4UF, this motor going, and this is not connected now. It's nothing but a flywheel now. Now I am going to connect this motor to the same power supply, so the 120 volts is going to be coming into both this and this when I make this connection here. There, now they're both going. This and this are both motors being run by the same 120 volts AC. And now look at the draw coming from the grid. There, see? That's so much. In my videos from a few months ago, it would actually get hot because there's so much current after a while. Okay, now I'm going to connect the 4UF run cap in series right here. This is the 2.27 amps is without this connected. Now I'm going to connect it. Look at that. Uh-oh. Had a problem. Hold on. Okay, I'm back. I got a little ahead of myself there. I forgot to disconnect this motor before I shoved those caps. In particular, this cap, I didn't have this motor disconnected when I did that, so I think it should work now. First, I'm going to connect this motor, permanent magnet motor, up to the 120 volts input. Okay, there we go. Now I get that really high draw. Now I'm going to disconnect this motor now. Disconnecting this motor. Okay, now now it's an AC motor here being powered by the grid. And now this is a flywheel doing nothing, okay? The pony motor is now a flywheel. I'm powering this. Again, it's really high draw. Now I'll do this cap right here. Now I'll do it. I'm sure this is going to work. There, I did it. This 4 UF cap is now connected. And it's 21. I think I need to go up to 5. Okay, I'm back. I had to bring this cap up to 5 UF, not 4 UF. Sorry about that. So now it's only drawing 300 milliamps, not 2.28 milliamps. So that's almost a reasonable level of input draw. Now only this motor's being powered. This is only a flywheel now. I'm running off 120 volts AC through a 5 UF run cap, not a 4. And I have a series cap, sorry. And now a 12.5 run cap here. So that's what I got going. So I kind of solved this problem. And like I said, I can really tune this. Play with different values for this. And bring the draw down some more. Now, let's see what we have across the run cap in volts and amps circulating. This will be interesting. Also, let's just grab the shaft. I'm putting a load on the shaft in my finger. Doesn't go up too much. Yeah, I'm squeezing pretty hard. So that's good. It's got good shaft torque, but I don't want to stall it right now. So that's a quick little test. Now I'm going to see what the voltage is across the run cap and see what the amps are circulating. So 1 second. Okay, amperage right now with this 12.5 run cap, and this is what's circulating. And I have a ammeter